we know that there are 350 grams of coffee beans, and each correctly poured over coffee requires 20 grams each. And we need to find the greatest number of properly brewed large mugs of coffee that can be made from these beans. So we can have less than the amount given, 350 grams of coffee beans, but we have to make sure, that each of these coffees are made properly with 20 grams each. So that just gives us 17 times 20 is equal to 340 um, grams of coffee beans used. 10 are left over because we cannot make another coffee that works, that is properly created. So the answer to this problem is clearly 17B. Now we're going to move on to problem 2. We have to see some pretty crucial patterns within the set of numbers. So we have the numbers 1, 2, 3, 4, 5, 6, and the squares, the units digit of the squares of these numbers is 1, 4, 9, 6, 5, 6, as given in the problem, as stated in the problem. We can continue on. So the square of 7 is 49. The units digit of that is 9. And then we can continue with 8, and that's 4, 9, and that's 1, 10, and that's 0. And then we see a repeating pattern that starts. So with number 11, the square is 121. The units digit is 1. For 12, it's 4. For 13, it's 9. And as you see, there's a repeating pattern that starts to occur. So every 10 numbers, there's a repeating pattern for every 10 numbers. And this will help us solve the problem because we're trying to find the sum of all the numbers Jerry wrote down, which is the units digit. So we can find the sum of one batch of 10 numbers and then multiply by the number of batches, and this will help us. So 1 plus 4 is 5, plus 9, 14, plus 6, 20, 25, 31, 40, 44, 41, 40, 45. So the sum of the units digit for the first 10 numbers, for the square of the first 10 numbers is 45. And then we see that each of the other, the numbers 11 through 19, the numbers 11 through 20 also have the same sum because they have the same units digit. So, and this makes sense because we see that the starting number is 1, the square of that is 1 as well, and then we only have to care about the units digit when we square a number. So 1 squared is obviously 1, 2 squared is obviously 4, and we can continue. So this pattern is very clear that we can see. Okay. And again, there's 2025 positive squares. So we know that there's 2025 numbers, and that makes it so there is 200. That makes it so that there's 202 batches of 10 numbers. Gives us a total of 2020 numbers, and there are 202 batches. So there are 200. The sum of the units digit for each one of these batches is 45. So 202 batches times 45 is, I believe, 9,000 plus 90. So 9,090 is the sum of the units digit. Because again, we have a sum of 45 for each of these 10 numbers, which is one batch. We have 202 batches, so multiply by 45 for each one of these batches, for all of these batches. So we have a sum of 9,090, but we aren't done there because we only counted 2020 numbers. And we can start the sequence over again. We have 2021, 2022, 2023. And they have a units digit of 1, 4, 9, 6, and 5. So the 2025th term has a units digit of 5. And then we have to add this on to what we have, the sum of the batches as we found earlier. And the sum of 1, 4, 9, 6, and 5 is 25. And we find that the sum of the units digit for all of these numbers, or the sum of the units digit for all these numbers, is 9115, or D. Answer choice D. We're going to move on to problem 3. Problem, again, there has to be a pattern, and especially in Pascal's triangle, because there are so many different patterns, and it's very interesting. Anyways, we can find a pattern by finding the sum of each row, of each of the rows. So we realize that the sum of the first row is 10, the sum of the second row is 11, the sum of the third row is 22, the sum of the fourth row is 44. And we see that there's a pattern because besides 10, the first row, we see that from the second to third, we are multiplying by 2. From the third to the fourth, we are also multiplying by 2. So obviously, you can take your time to prove that, but in this case, we will move on. So since each of the rows we are multiplying by 2, we know that it is very easy to find the sum of the numbers in the 11th row, because let's label the rows right here, 1, 2, 3, 4. Because if we start on the second row, for example, not the first row, the second row, we have a sum of 11. And then in order to get to the third row, we are just multiplying by 2. Or to get the sum of the third row, we're just multiplying by 2. And in order to get from the second to third row, we have to add 1 row. And if we did it with the 11th row, so if we move down to, let's just say, 11 right here, 10 right here, 9 right here, we have to add 9 rows to get to the 11th row. Basically, we are multiplying by 2 to the power of 9, because each of these rows, each of these gaps, we are multiplying by 2 to get to the sum, of the next row. So again, this kind of makes sure that we didn't make any silly mistakes or count the rows wrong. So from the second to third, again, we add 1 row and then we multiply by 2. If we get to the 11th row, we add 9 rows and then we multiply by 2 to the power of 9. 2 to the power of 9 is 512 times 11, which is 2, 3, 6, 5. So 5,632. That's the sum of the numbers in the 11th row. And then we're trying to find the sum of the digits of this number. So we have 5 plus 6, 11, plus 3 is equal to 14, plus 2, again, is equal to 16. So the answer choice is D. Now we're going to move on to problem 4. So this is a base problem. So we have the number AB, it's in base 7, and BA, it's in base 9. Now we can convert AB and BA both into base 10 by multiplying by the value of each of its digits. So this is in the second to smallest digit. So we have 7a plus b. So we have 7 to the power of 1 times a, and then 7 to the power of 0 times b. That's how we convert into base 10. And then this is equal to 9 to the power of 1 times b plus 9 to the power of 0 times a. And that's just 9b plus a. So they are equal because, again, they're both in base 10. We converted both of them in base 10, made them equal. Again, if you want me to cover bases in another video, please let me know, but this is how bases work. Okay, so we have 8b is equal to 6a. That means we can simplify this. 3a is equal to 4b. And then we're trying to find one value of one value and the only value of b and a that work, and we're trying to find the sum of a plus b. So we know we can automatically see that 4 and 3 work. So a is equal to 4 and b is equal to 3. And we can plug them back into the original equation and see if they work. So we have 43 base 7, 34 base 9. And again, it works because no number is larger than 7. So that makes it a 2-digit number. So we have 34 as well, and its no number is larger than 9 as well. So we want to make sure that is true. So it works because 28 plus 3 is equal to 27 plus 4. They both equate to 31 in base 10. And it's asking for a plus b. So 4 plus 3 is equal to 7. The answer is A. Now we're going to move on to problem 5, EAO. So it's a geometry problem. We have to draw the figure to the best of our abilities. So we have 130 degrees. This is angle B. It's part of triangle ABC. AC is equal to 18. AB is equal to 10. And O is the center of the circle containing points A, B, and C. So we know that it's 90, since it's not angle B or any of the angles of the triangle is not 90 degrees, we know that the diameter is not, the center of the circle is not on the diameter. So we're going to draw a pretty accurate diagram. I guess that works. We have center O right here. And it's saying let O be center. What is the degree measure of CAO? So we can draw the radii or radiuses from the center of the circle. So we have AO is a radius. It's congruent to OC because OC is also a radius. It's also on the circle. And then B is also on the circle, so that makes it a radius as well. Without loss of generality, we know that ABC could be a isosceles triangle, for example. Isosceles triangle with AB and BC being the sides that are equal. So just set these two sides as equal. This makes it so these two angles are equal. These two angles are equal, CAB and ACB. So this divides the radius OB divides angle B in half. So we have 65. This is a right angle because, again, ABC is isosceles. So we know that angle CAB and ACB are both 25 degrees because of complementary angles. Okay. And then we also know that these two sides, OA and OB, are the same because they are both radiuses radii or of the circle O. So we know that OAB is 65 degrees, and then we just perform subtraction. So 65 minus 25 is 40. So we know that the angle CAO is 40 degrees.